All right, geometry folks, this is 5.2. We're talking about similar polygons. We talked a little bit about what it means to be a congruent polygon, and like I said before in previous videos, the term similar has a very, very distinct definition in geometry. So what does it mean to be similar? Similar simply means all corresponding angles are congruent, all corresponding sides are proportional. All right, that means that they're going to have the same measure all the way around. So if I look at this, all right, A and W are in the same location, they're corresponding, they're also congruent. B and X are corresponding and congruent. C and Y, Z and D. Those corresponding angles are congruent. Now if I look at the sides, you've got 18 over 6 here and here. You've got 15 over 5 here and here. You've got 21 over 7. And you've got 12 over 4. Please notice how all of these are a fancy way of saying 3. That means that they are going to be proportional. Now this also would be referred to as a scale factor. All right, going from this to this, I have to multiply it by 3. And now somehow I've created a really weird looking work of art instead of 2 4-sided figures. I do apologize about that. Okay, so FJH is similar to JKL. Please note that is your symbol for similar. It is very close to congruence. It is similar to congruence. So we've got congruence. Let me try this again. That was a minor failure on my part. So we've got congruent, which literally means has the same measure. We have equal, where you say 2 measures are equal. And then we have similar. Similar means corresponding angles are congruent, and corresponding sides are in proportion. So we have F, J, H, and JKL. So F matches up with J, G matches up with K, H matches up with L. So list all pairs of congruent angles. So my congruent angles, well, angle F is going to be congruent to angle J. Angle G is congruent to angle K. Angle H is going to be congruent to angle L. So those are going to be the congruent angles. Now, how do you write the proportion that relates the sides? Well, here's how I do that. All right, if I'm going to start off with, let's just say FG. Well, FG corresponds to JK, but I write it in ratio form. Then I'm going to say that's going to be equal to the next set. So if I say GH, what matches up to GH? Well, KL. And that's going to be equal to, what do I have left? FH over JL. This is how you write the sides in proportion, right there. Those are all going to be in the same proportion, and that's how you write it. So ABC, XYZ, state the scale factor. The scale factor, if you're going from ABC to XYZ, this is your dead giveaway. So going from 6 to 3, you would divide by 2. A scale factor means is that you're multiplying. So how do you represent divide by 2 as a multiplication? Well, that's just going to be multiplied by 1/2. So there's your scale factor, just 1/2. 6 times 1/2 yields 3. So you're given a picture that was 4 by 6. You wanted to resize it so that would fit into an 8 by 10 frame. Would your picture remain in proportion? So what that is simply asking is 4 over 6 equal to 8 over 10? And this simplifies to 2/3. This simplifies to 4/5. Was that in proportion? Absolutely not. So no. Nope. Determine if these triangles are similar. If so, write the similarity statement and scale factor. Okay, so these two are obviously congruent. These two are obviously congruent. So that means P and T have to be congruent if those are truly triangles. So we're off to a good start. Yeah, all the corresponding angles would be congruent, okay? So if I'm going to say that NQP, the triangle NQP would be similar to triangle RST. So far with the angles, we're good. Here's where things get a little bit tricky though. Here's where I got to test. So NQ is 12.5. And that matches up to RS. QP matches up to ST. So I got to ask, is 11.5 over 9.2 there? And the last one, 15 over 12. So I have to look at, are those proportions all the same? Well, 15 over 12 is nothing more than 5/4, so that'd be like 1.25 as a decimal. 12.5 divided by 10 is 1.25 as a decimal. So far we're looking good. This is also 1.25 as a decimal. So all three of these are the same. So yeah, here's a similarity statement, and the scale factor, well, just comparing them, it's 1.25. So the scale factor is actually going to be my proportion flipped over. Like to get from 15 to 12, I would have to multiply by 4/5 instead of getting the 5/4. So I'd have to multiply by 4/5. That would be my scale factor. What would I multiply to get from the first one to the second one? So A, B, C, D, E, F, V, W, Y, Z, find the value of X and Y. So it's in proportions. Now, we've got to figure out what am I comparing here. So AF links up to VZ. So 12 over 3y minus 1 would be equal to CD matches up to WY. So CD matches up to WY, so that's 9 over 6. So if I really want to be clever, I'll simplify this. 24 equals 9y minus 3. So 9y equals 27, so y is going to equal 3. All I did was look at my similarity statement to figure out what went with what. I figured out 9 goes with 6, 12 goes with 3y minus 1. So that's what I did. I used the same shape on top and same shape on bottom. So now how do I figure out x? Well, x matches up with 10, okay, corresponds to 10. They're in proportion. They're not congruent. So, but I'm going to use that same concept, x over 10 and 9 over 6. So x over 10, 3 over 2. So 2x equals 30. X had better equal 15. So perimeters of similar polygons. Perimeter, nothing more than distance around the figure. You know, if you walk around the figure, count how far did you go. So two polygons are similar, then the perimeters are proportional to the scale factor between them, which I kind of hope makes sense. So like this is 4, this is 5. They've all got to figure out that they've all got to fall into that same proportion. Actually, don't do that. Don't go 4 and 5. This one looks bigger. So if I say like this is 3, this is 4. Say this is 6, this is 9. That doesn't seem right. 3, 4. It's not 6, 9. Sorry, dude. 9 and 12. And then so let's say like this is 6 and this is 8. And then this is 12 and this is 16. So if they all if they're all on that same scale factor, you know, 4 over 3 would be my scale factor 3/4. Then the perimeters simplified are also going to be 3/4. And so if I compare the perimeters, simplified, it's going to be that same scale factor. So find the scale factor of A, B, C, D, E to P, Q, R, S, T in the perimeter of each polygon. So if this is 8, this is 8, this is 4, this is 4. So this is 3, this is 3. So 4 matches up to 3. Those are in the same location. So that means that my scale factor is going to be 3/4. So 6 times 3/4 is going to give you ST. 8 times 3/4 is going to give you these two. Well, that means that this is 6 and this is 6. 6 times 3/4 will give you 18/4, which will be 4. Don't know what I was thinking. 4.5. So if I compare the perimeters, 6, 4, 4, 8, 8, 16, 20, so that's going to be 30. Perimeter over here, 9, 9 is 18, and 4 is going to be 22.5, which is going to be the same scale as 3/4. Confirm that with a calculator. Yeah, that's going to be the same thing. That's what they're saying. The perimeters follow the same thing as the scale factor. So A, B, C, D, E, R, S, T, U, V, find the scale factor in the perimeter of each polygon. So the scale factor, well, here's my tip-off right here. Oops, 7. So I go from 4 to 7. So my scale factor, so since I go from 4 to 7, my scale factor is going to be that flipped over 7/4. Okay, so 6 times 7/4 this is going to be 10.5. And since this is 10.5, but I'm going backwards, I'm going from 10.5, I'm going backwards over to here, I'm going to multiply it by the reciprocal. So that's going to be 6 and 6. So this is 10.5. So 6, 6, 6, 4, 4. This is going to be a scale factor of 26. 10.5, 10.5, 10.5, that's 31.5. And 14, that's 45.5. And that's going to fall into that same category of 4/7. Okay, that's all I got. Come talk to me with questions. Remember, everything's got to boil down to the scale factor, and you've got to be able to go forwards and backwards with it. That's all I got. Well, have a nice